Today I'm going to explain the code of my project. So my project is nothing but to find the path prediction and the user action. So first of all, I'm gonna explain the accuracy of the path prediction. So I have run two different kind of test cases. Uh, I have run the programs and find out the which of the programs giving me more accuracy. So first is this practice PY. Here what I have done is I have every day I used one GPS locator and tower collector application, and when I move from one location to another location I have recorded all the data which includes cell ID, Calton, latitude, longitude, date and time. So first of all what I have done is I have collected that data set and I have merged that data set into one data set named dataset tower final.csv. On that I have run some test cases and I have used one algorithm and then find out that the accuracy is what. So for finding the accuracy I am using this algorithm named skeleton. So as we all know that in many machine learning or data science activities the data set might contain text or categorical values. So one thing is noticed that most of the algorithms work better with the numerical values. So main advantage is faced by an analyst is to convert that text or categorical data into the numerical data. And this performance measure for the machine learning classification problem where output can be two or more classes, which is nothing but the scalar. So in this we take the actual values, we presume some values and identify the new values. And this way we can find out the precision, speciality, accuracy and the curve. So after accuracy and some random forest, I have predict some value. I use this scalar diagram and when I run this program, it will give me some accuracy. But sorry, it will take some time to figure out the accuracy. So until then, I will show you the next test cases which I have used. So for that, I also take this same data set which has cell ID, latitude, longitude, and latitude. And by using it, first what I will do is after collecting all the data set of my final data set, I will split the function. I will split this function and use the train state splits to split the function, and after that I will find out that after generating some forecast classifier I will print out some accuracy which can predict the performance. So here you can see that this is the test one which has result of accuracy something zero point 0.9. When I run the test case number 2, it will give me accuracy nearby zero point 0.4 to zero point 0.5. It means that my skill and learn algorithm is more specific compared to the splitting algorithm. So here you can see its accuracy is nearby 4.449. So this way we can find out the difference. And one more thing, like what I would done is I am doing some graphing. If I do some graphs, then I can identify and predict. So by using some online tool, I have predict some of the graphs. Let me show you there. Here, I have forgotten where I plot the graph, so I will show you here. So this graph will show you some path prediction, like from this point to this point I am going, then from this point to this point I am going every day, and from this to this. So if I want to predict my another day's task, you will predict from this area that where I'm going from which point to which point. So my next project definition was physical movement. If I move from one point to another point, I am maybe running, walking. Sometimes I'm upstairs. Sometimes I do downstairs. So this kind of activities I am also capturing through one app named Science Journal, and it captures some running, walking, sitting, sleeping, upstairs, downstairs, this kind of activities it is performing. So for that I am using Jupyter Notebook, and I have collected all the data in this applications. You can see here all the data are here in .csv files. I have collected not one but more than 4 to 5% data, so I can check. So first of all, what I have done is I have collected all the data, and after collecting it, I have saved in .csv files. And after all the data collecting, what I'm doing is I am doing data pre-processing to store all the data into one file. So here you can see that after importing and collecting all the data, my all the data will be collecting and stored in this final data.csv file. So after collecting all the data, what I will do is I will perform some human activity recognition algorithm to find the accuracy, that the what kind of algorithm gives me more accuracy as I do for the another application. So here I have used same sklearn algorithm to check. As well, I have used some others as well. I will show you that. So what I will do is first of all, I am showing you the my final data set here, which is looks like this, which has more than 7 this rows. Then what I'm doing is I am defining is according to the activity. Here is the username, here is the activity. So this is for the sitting activity. Now what I'm doing is I have done some training and testing set. I have taken that training and testing set and I'm applying some different kind of algorithm on the training set. So make sure that the performance of the model is stable or not. So first I have taken the data and splitting the data into testing and training set. After that I am taking one model that is name is naive base. So this kind of model is I didn't create it, it is already there, I'm just using it. So I just feed that my training and testing data into algorithm and find accuracy. This has accuracy something nearby 66%. And after that I'm using linear svc. So in the linear svc, my model has svc model and it has some data train and target train, and it predicts the test data, and after the prediction of this, accuracy will be something nearby 85%. And after that I have used the neighbors classifier. Here also the accuracy will be something nearby 97%. So you can find in the accuracy. So after finding the accuracy, I will compare the performance of the all the algorithms like naive base. Then I also use the algebraic classifier. Then after so you have not an idea about some of the algorithms, which is like as I already told you that normally we get the data which is normally in the numerical form. Instead of numerical form, it must be in the text or a categorical values, but to perform some algorithms we need it to in the numerical value. So for that we use the label encoding, which is very simple, and it is involved converting each values in the column to a number. So after we convert into column of numbers, it only gets two values. One is 0 and one is 1. So 0 means loss and 1 means won. So here I am doing this only won or loss. So that's the only requirement, because in the skill and train, what it will do is first it will predict the value. Like predict the value means it is possible that it is pass or fail. If we predict pass and it will fail, it means that is a false prediction. Okay, so this is how it works. So generic function to run any model specific, this is the algorithm which is used to train the model and predict some test data and then calculate the accuracy of the model. After that I'm using the confusion matrix. So confusion matrix is the one I will show you how it works. Confusion matrix is somewhere here. Let me run and show you. It will show some confusion matrix. Mm, So these are all the different kind of regression I have used. So after using some linear SVC, kernel SCM, decision tree, random focus plus, at the end you can see that what kind of accuracy it is giving you and what kind of errors it is giving you. So you can predict something. Let me show you the accuracy matrix. And here you can see that at the point of time, what kind of a label I can give you for the setting. So this is nothing but the accuracy model I have talked to you about, that confusion matrix. So in the confusion matrix, this side on the left hand side, all the values are the preferred values, and on the all the values on the left hand side as the preferred value, and on the upper side all the values that must be the actual values. I'm not sure why it's giving error, because before that it was running perfectly. Maybe I missed something, I guess so. That's why. So here I can show you some examples of the graphs. So if I run all the values here you can see some data by activity type, like the person is most of the time it is sitting, sometimes in walking, downstairs and upstairs ratio are very low. So by looking of this graph, you can identify that which person is more active and which persons are sleeping all the day, right? And this is also useful for the persons who are physically challenged, or for that, like it has to move for certain period of time in the whole day. So the doctor can advise and use this application. So after if you use this application, it will show some accelerometer graph, and it shows like this while it's sitting or while it's walking. So here are some graph while walking like this and while downstairs like this. So you can identify these things. Thanks. Today I'm going to explain my project about mobility path prediction and the human activity recognition. So first point is the human path prediction. So first of all, if I want to predict something, I want to first find one kind of algorithm which predicts some accuracy. Like, so I already explained in my code video that how I have written down two test cases, and after these two test cases I find it out the accuracy of this. And here also you can see that this that prediction test number 2 has accuracy something nearby 0.44, while the prediction test number 1 has a accuracy nearby 0.9. And after that I have also drawn one chart which shows normally nothing, but it shows some longitude latitude ratio that it is increasing. And I also plot one graph. So here I will show you that how I can print one graph using latitude and longitude. So let me first find it out. Latitude, and in the y-axis I will draw some longitude. And here this is a scatter plot, but this scatter plot will show some accuracy, like from this point to this point I'm going every day, and after this graph I will predict for the future that for tomorrow this time I will be something nearby this point. So same way, if I am going from somewhere to somewhere, if I want to measure my physical movement, like I am walking or running upstairs or downstairs, for that also I have created applications. So I will also show you my data settings. So this is for GPS data settings. For collecting a data, I have used three different applications. First is a GPS collector, second is a tower collector, and the third is a science journal to collect my physical movement. So in the tower collector application, I collect the tower locations, and uh, in the GPS collector, I will collect some data like longitude, latitude. So I will find out my physical position, at what time I am where. So um, in in my physical moment, I also collected all the data and generated one final data set. So in final data set, there are more than 4% data is collected, which has some activities like sitting, then walking, then downstairs, upstairs like that. So after collecting that kind of data, I have plot some graphs which shows that a person is sitting at that time or sleeping at that time. And here you can say this graph will shows you my activity for during the day for person. Like for one day, if I collect for the whole day, if I collect the data and create a graph, then it will show you that how much percentage of time I was sitting, walking downstairs or upstairs. So this application is basically used for the patient, or you can also use as your exercise. Like if you want to decide that for 30 minutes at least I have to walk, or at least only 5 hours maximum I will sit unless I will walk or run. So by this application you can manage your task and you don't have to think more about it. You just have to show in the application, it will show you the graphs. And this also the graphs which in the accelerometer shows you that while if you are sitting, then which kind of accelerometer graph it will create. If you are walking, then which kind of graph. If you are upstairs, then there is so much fluctuation in the graph. While in the downstairs, all the graphs are most of in the downside. So all the graphs are taken as in a XYZ axis. So in the XYZ axis, if I am upstairs, my Z axis graph is upstairs. If I am downstairs, my X axis graph is downsides. And while I am walking, then the Z axis graph is showing downsides. And while sittings normally graph should be straight. So first is make some musical movement and then I sit, then it goes continuous. Like there is no movement, then it's a straight line. If there is movement, then it's fluctuating like that. So you can identify that which kind of movement you are doing during the day and how to manage that kind of movement. Thanks.